Okay, so this is 6.6a. And up to this point with radicals, we have learned how to simplify them. And now we're going to learn how to solve them. So that means we're going to have equal signs. Okay, one of the things we're going to end up running into when we're talking about radicals and equations is we come up with this weird new word. If you can read my writing, this is an E and an O, and that word is extraneous, which means we will come up with an answer for x sometimes, but because we're dealing with radicals, sometimes when we get a number, let's say we got 3 for our answer, and we take it and we plug it in the original problem, it doesn't give us a true statement. That does not mean that we did the math wrong. Well, sometimes it does, but it could very well mean that we have an extraneous root or an extraneous solution, meaning that it works algebraically, but when we plug it back in, it doesn't work because of that doggone radical in squaring both sides and, doing that kind of stuff. So this first one we're going to do does not have an extraneous radical, but let's go through the rules as far as how this works. If we are trying to get rid of a radical, and then we can just solve for our numbers here. We don't have a radical anymore. If we take everything in the radical and square it, remember if this number here and this number here are the same, then it takes the radical sign off, the parentheses, the exponents. It takes everything off except the 3x plus 4. But we cannot square both sides or square that side unless we square that side too. So once we do this, this changes to 3x plus 4, and this changes to 25. Now we just have a simple algebra problem. Okay, now that's our answer. Now if we put 7 back into our original problem, we get the square root of 21 plus 4 equals 5. Square root of 25 equals 5. That is a true statement, so I know that I do not have any extraneous roots. Well, let's try one with an extraneous root, just to give you an idea of what that looks like. Okay, so again, we square both sides, gets rid of the radical, add 7 to both sides. Oops, I'm sorry. That's a 16, isn't it? Okay, divide by 4, x equals 4. Now let's take that and put it back in the original problem. Square root of 4 times x was 4 minus 7 equals 3. 4 times 4 is 16. 16 minus 7 is 9. Does that equal 3? Yes, it does. But if we were to make one little change here, let's say that we change this to a minus 3, and we squared it. Everything works the same, right? Negative 3 squared is 9. We add 7 to both sides. We get our 16. Everything works, and we get 4 for an answer. But let's plug that in, and we notice that 4 times 4 is 16, minus 7 is the square root of 9, and that does not equal negative 3. The square root of 9 is 3. That does not equal negative 3. So that means 4 is the answer, but it's an extraneous root. And not only that, it's the only answer we get. So therefore, there is no answer that makes that correct. So 5x minus 1 square root plus 3 equals 7. Now we have to isolate the radical. So remember on these other ones I had, when we had this one, before there was a squared or anything on here, it didn't have anything else on this left-hand side except the radical. Now look at this next one we're doing. This has something over here in addition to the radical. So when it has that, we do what's called isolating the radical. We get the radical on one side of the equal sign by itself, which means we have to get rid of that 3. All we have to do is subtract it from both sides. And now we have square root of 5x minus 1 equals 4. Now, it makes it so much easier because we just square both sides. And everything goes away over here. And we get 16. We add 1 to both sides. And x equals 17 over 5. Now, I will tell you that when you put this back into the original, it does work, so it's not extraneous, and you don't even have to check it because I already did for you. And it does work, so we don't have an extraneous root. Bringing us to example number 4, which is t plus 5. Ooh, that's a pretty cool looking t. Okay, do the exact same thing. Square that side. Okay, remember, I'm squaring both sides. I'm not squaring each term on this side. I'm squaring the whole thing, which means that takes me to using the FOIL method. Okay, equals. Okay, so far everything is the way you've done it in the past. So I'm going to subtract t from both sides. And that gives me a plus 9t. Subtract 7. And I get a plus 18 equals 0. Make my handy dandy little parentheses here. And I've got a t there, plus a plus, and a 6, and a 3. Then I do what I've been practicing. First term, or first parenthesis. Second parenthesis. So t equals negative 6, or t equals negative 3. I try both of those, and I discover that my negative 3 works when I put it back here. My negative 6 does not work. So example 5, page 545. Now, look, this x minus 3 and x minus 3 are here, but this has a radical over the whole thing. This only has it over the x. So I'm going to take the square root, I'm going to square both sides. This one's easy because I get x minus 3. This one I have to use the FOIL method. So when I do that, I get, in fact, let's go ahead and do that over here. I want you to see what happens. Oops. Okay, first, square root of x squared, because I multiplied the square root of x times the square root of x. Okay, outside, inside, last. Okay, square root of x squared. Remember, if I've got an index there and that, everything goes off. This I can combine. Okay, so that is x minus 6 square root of x plus 9. Let's get rid of all this here so it's not getting me more confused. All right. Now, we still have a radical in our equation. We can't do anything else with that radical except get rid of everything except the radical. So what I'm going to do is I'm going to subtract x from both sides. So I get negative 3 equals negative 6 square root of x plus 9. Subtract 9 from both sides. So I have negative 12. Divide by negative 6. And I get 2 equals the square root of x. Now I can square both sides because all I have is the radical. I isolated it. So this becomes an x. 2 squared is 4. Okay? And I do all that work. I plug this back into the original, and it doesn't work. Because 4 was our only solution, there is no solution to this equation. So there we go. Okay, so we've got 4 more examples. I'm going to save these next 4 examples for the next video.